Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So yes, now we have already done with physical chemistry, inorganic chemistry, and today we are going to enter to the world of organic chemistry with our first chapter, that is haloalkanes and haloarenes. Okay, so today we are going to cover the very basics of this topic, that is nomenclature, classification and structure. Okay, so these will be very I'll be doing lot of practice questions and will also be solving some PYQs from this. Okay, so please follow this series if you want to hit that perfect 60 score in your KCET chemistry examination. So yes, every day we are having classes at 6 p.m. so I request all of you to join our WhatsApp channel, because it is whatever notes that we are providing, the question papers, the solutions, everything will be given in our WhatsApp channel. Okay, so please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video. Okay, so yes, I hope all are ready to start with organic, and please sit with a notebook and a pen so that we can make notes together and study together and can complete this portion of this chapter entirely in just 1 to 1 hour, 1.5 hours. Okay, everything will complete. Let's get started without any delay. Okay, so yes, if you want to see how are we going to cover this chapter, so basically we'll be having 4 parts in this chapter. Okay, the first part, that is today's class, will be doing classification, nomenclature and nature of CX bond. Okay, now coming to part 2, in the next class we'll do preparation of haloalkanes and preparation of haloarenes, and then we'll also study about physical properties. Now coming to part 3, here we will be discussing about the chemical reactions of both haloalkanes and haloarenes. Then coming to part 4, here we will be doing polyhalogen compounds. Okay, so this will be the, I can say, the structure of this particular chapter. 4 lectures will come. First lecture these 3 topics, second lecture these 3, third say this one, and fourth this one. Okay, I hope this is clear. Okay, so now coming to the next one, that is weightage, how much we are getting every year. So you can easily expect 2 to 3 questions from this chapter in the last 4 years. Okay, easily you can expect 2 to 3 questions. Now coming to the first part, that is today's topic, what are we going to cover? Classification, nomenclature and the nature of CX bond, as I have already told you. Okay, now let us move towards the classification. So first of all, to understand classification, there are 3 bases of classification. Okay, the first one is the number of halogen atoms, second one sp3 CX bond, and third one sp2 CX bond. Okay, so let us revise again. The classification we have done on 3 bases. First is the number of halogen atoms, next one is sp3 CX bond, and the next one is sp2 CX bond. Okay, so before going these all topics, let us first understand what is haloalkanes. Okay, what is haloalkanes and haloarenes? The topic name, what does it mean? Okay, that we should know first. So now see, any X means your the halogen group, when it is attached to any alkyl group, we can say, so for example C or CH3. Okay, if it is attached to any alkyl group, the halogen part, we call it haloalkanes. Now if this halogen group, okay, is attached to any aromatic compound, okay, then we call it haloarenes. I hope this is clear, haloalkanes and haloarenes. Okay, now coming to the classification, as we have discussed, number of halogen atoms, sp3 and sp2. Under sp3 we have these 3 alkyl halides, allylic halides and benzylic halides. Do not worry, we will go with example of all this. Then in sp2 CX bond we have vinylic and aryl halides. Okay, fine. Now coming to this one, the first one, that is number of halogen atoms. So see, if there is only one halogen atom, we call it monohaloalkane. Okay, if there is 2 halogen atoms, we call it dihaloalkane. If it is 3, then we call it trihaloalkanes. These are haloalkanes. Now coming about haloarenes, if there is in the aromatic ring, if there is only one halogen group attached, then we call it monohaloarene. If in the benzene ring or in the aromatic ring there are 2 halogens attached, we call it dihaloarene. And if in the benzene ring there are 3 attached, then we call it trihaloarenes. Okay, very simple. 1 halogen attached mono, 2 di, 3 tri. Haloalkanes or haloarenes depends whether it is attached to alkyl group or aryl groups. Okay, Fine. Now coming to next one here. As I told you, sp3CX bond, the next category. So here if you see the first one, on the basis of this one, see, this carbon, this halogen, okay, is attached to one carbon. Now this carbon is attached to another carbon, okay. The carbon containing the halogen is attached to one more carbon. Then these type of carbons or these type of haloalkanes are called as primary haloalkanes. What I am saying, let us repeat. Suppose this is a carbon, okay, and this carbon is connected to, this carbon is having the halogens. Now this carbon is connected to only one carbon next. Then we call it primary haloalkanes. Carbon which contains the halogen should be attached to only one carbon, okay. Carbon which contains the halogen should be attached to only one carbon, then it is called as primary alkanes or primary haloalkanes. Now if you see next one, see, the carbon which is containing the halogen, this is the carbon which is containing halogen. Now this carbon is connected to two carbons, right. This type of haloalkanes are called as secondary haloalkanes. Carbon which contains the halogen or which is attached to the halogen is attached to another two carbons, okay, that is called secondary. Next here, carbon which contains the halogens, it is attached to another three carbons. Carbon which contains the halogen is attached to another three carbons, then it is called as tertiary haloalkanes, okay. So based on your first alkyl halides, we have three categories. Carbon which is attached to halogen is attached to only one carbon, that is called primary. Carbon which contains the X is attached to another two carbon, that is called secondary. Carbon which contains the halogen is attached to another three carbons, that is called tertiary, okay. Fine. Now coming to allylic halides. Now see, carbon which contains the halogen is attached to another carbon which is having double bond, that is called allylic. Now for example, you see, if I just do like this, one structure, okay. Now see, this carbon is containing the halogen. Now this carbon is attached to this carbon which is a part of double bond. Then we call it allylic halides, okay. Such type of halides, carbon which contains the halogen is attached to a double bonded carbon, then it is called allylic haloalkanes, okay. Now benzylic is that the carbon which contains the halogen, see, carbon which contains the halogen should be attached to the benzene ring. Carbon which contains the halogen should be attached to the benzene ring, okay. Let's revise all these three again. The second category of specification is sp3 and CX bond. The carbon having sp3 hybridization should contain the X. Now if this one is attached, the carbon which contains the X group is attached to only one carbon, then it is called primary. If the carbon which contains the X is attached to two carbons, it is called secondary. If the carbon which contains the halogen is attached to three carbons, we call it tertiary. That is the first thing. Next, coming to allylic halides, the carbon which contains the X should be attached to a double bonded carbon, that is called allylic. Next, the third one, the carbon which contains the X should be attached to a benzene ring, okay. So that is called your benzylic halides. Fine. Now coming to the second type of classification, that is sp2 and CX bond, means the carbon which contains the X should be a sp2 hybridized carbon, okay. So now if you see here, there is one, that is your vinylic halides. So vinylic halides means, okay, vinylic halides means carbon which is, this carbon is sp2, right, one second, yeah. So this carbon is sp2, this carbon directly contains the X, that means we call it as vinylic halides, okay. Here also you can see carbon, the sp2 carbon containing the halogen is called as vinylic carbon. Now coming to aryl halides means the halogen is directly attached to the aromatic ring. Halogen directly attached to the aromatic ring is called as aryl halides, okay. So here you can see this is also example of aryl halides, okay. Let us understand all the classification once again. First is based on the number of halogen atoms, mono, di, tri, we can use like that. Second is sp3 carbon should contain the CX, means the halogen. Here we have for alkyl halides primary, secondary and tertiary. Then we have allylic and then we have benzylic. Now coming to sp2, here we have vinylic, means the same carbon which is having double bond should be having a X group or should be having one halogen group, okay. And then we have aryl halides, okay. So here the aromatic ring directly contains the X group, okay. Now coming to the next one, let us do some question here. So first one is, among the following the examples of tertiary alkyl halide is. Tertiary means what? The carbon which contains the X or the halogen group should be attached to 3 other carbons, right? That is called tertiary. Now if you see here, let us check option number A. So this carbon is having Cl, so I can just draw like this one CH3, okay. Then we have CH2, then we have C, we have Cl, and this side we have CH3, and then this side also we have CH3. Okay. Now if you see this carbon which is containing the halogen is attached to 3 other carbons, right? So yes, this is a tertiary group. So the correct answer for this question will be option number A. Now if you see the second one, okay, here the carbon which contains this X group is attached to only one group, one carbon, so this is primary. Here if you see the carbon which contains the X group is attached to 2 carbons, this is called secondary, 2 degree. Okay. Now if you see here, carbon which contains the halogen is again attached to 2 carbons here, so this is also secondary. Okay, fine. So let us see the second question here. The compound which contains all the 4, that is primary, secondary, tertiary and quaternary carbon atom is. Okay. So now if you see the first option, 3,3-dimethyl pentane, let us draw the structure here. So we have pentane 1, 2, 3, 4 and 5, okay, and then we have on the this one 3,3-dimethyl pentane, okay. So here if you see, we have a quaternary carbon because this carbon is attached to 4 carbons, this is quaternary. We do not have any tertiary here, right? Tertiary means the carbon should have attached to 3 other carbons, right? So if you see this one is a secondary, this one is also secondary, right? So I'll write here. So yeah, this carbon is tertiary, is quaternary because it is attached to 4 other carbons. This carbon is attached to 2 carbons, so it is secondary. This is also attached to 2 carbons, so this is secondary. This is attached to 1 carbon, this is primary. This is also attached to 1 carbon, this is primary. This is also attached to 1 carbon, this is primary, right? So we do not have here 3 degree carbon, so this cannot be the answer, okay. Next coming to 3-chloro-2,3-dimethyl pentane. So we have 3-chloro-2,3-dimethyl pentane, okay. So we have 3-chloro and 2,3-dimethyl. Okay, so 3-chloro, right? We can have like this. Okay, let me draw the structure first. So we have here 3, I'll number it here. So 3-chloro and 2,3-dimethyl pentane. Okay, this is 1, 2, 3, 4 and 5. Now if you see here, this carbon is attached to 3 carbons. So okay, first we will go, this is primary carbon because it is attached to only 1 carbon. This is a tertiary carbon. This is tertiary because it is attached to 3 carbons. Now if you consider this one is attached to 1, 2, 3. This is also tertiary. This is attached to 2 carbons. This is secondary and this is again primary. So here we are not having any quaternary carbon. So this cannot be the answer. Now coming to 2,3,4-trimethyl pentane. So if I draw this one, so we have 5 first and then 2,3,4-trimethyl pentane. This is the structure. So if you see here, this is primary, it is attached to only 1 carbon. This is tertiary because it is attached to 3 carbons. Now this is again primary attached to 1 carbon, this is primary attached to 1 carbon, this is also primary attached to 1 carbon, this is also primary. Now this one if you see, this is attached to 1, 2, 3, this is tertiary and this is also tertiary. So here also we do not have any 4 degree carbon, so this also cannot be the answer. The correct answer for this question is none of this, okay. Fine. Now let us go to the next question here. Okay, so next we are talking about nomenclature, okay. So how do we name the compound? So this is very important, common names you should remember. So and then you have to take the for the position of the carbon which contains the halogen and then the parent name of the halogen. Like for example, if you see this compound, okay. Now for example, if you see this one, okay. So on the second position we have chlorine. On the second position we have chlorine, so that is called 2-chlorobutane. Okay, but the common name is more important here. One second. If you see 2-chloro, so we have this one 1, 2, 3, 4. Okay, and we have this one chlorine. Okay, so these type of compounds are called as secondary butyl chloride or sec-butyl chloride. Okay, please remember the common name. Then you have this compound. We have 1 carbon and then it has 3 CH3. Okay, and then it has CH2 and then it has Br. Right. So now if you see, this is 1, 2, 3. So 1 bromo, 2, 3. This is 1 bromo, 2, 2-dimethyl propane. Okay, but that IUPAC name you can do, but the thing that you have to remember is this is called neopentyl bromide. Okay, this is called neopentyl bromide group. So this group, see, if in the secondary carbon there is a chlorine attached, we call this sec-butyl. This carbon group, this we have this structure, right? This is called neopentyl group. To the neopentyl group, one bromine is attached, that is called neopentyl bromide. Now if you have like this, we have like this. Okay, so this one is a tertiary carbon, so this is called tertiary butyl bromide. Okay, next if you have chlorine attached to a sp2 carbon, then it is called vinyl chloride, and if you have chlorine attached to an allylic carbon, then it is called allyl bromide. Okay, then if you have, we come about haloarenes, then it is called like ortho position, orthochlorotoluene. Okay, then you have benzyl chloride here, CH2Cl2, methylene chloride, chloroform, you should remember the common name CHCl3. Okay, that is CHCl3, bromoform is CHBr3. So these are the important compounds that you should remember. Okay, CHCl3, CHBr3, CCl4 is carbon tetrachloride, common name, IUPAC name you can write. I am talking about the common name. Now here it is N-propyl fluoride, 1-fluoropropane. Okay, we'll do questions here, then you will be more clear. Okay, so now coming towards the question, you have to write the IUPAC name of the following compounds. Okay, let us start then. Okay, the first one, if you see, when double bond is there, okay, so double bond is given more preference than the halogen group. Okay, so what I'll do, I will number it from this side. This is 1. Okay, 1 second. Okay, so this one is 1, this is 2, this is 3, this is 4, and then this carbon is 5. So on the 4th position bromine is present, right? On the 4th position bromine is present. So what will be the name here? I can write it as 4-bromo. Now let us see the second one here. Okay, so if you see, as I told you, double bond should be given more priority. So this carbon is 1, this is 2, this is 3, and this carbon is 4. So if I see bromine is present on the 3rd carbon, right? So what will be the name? So I can write the name for this one here. So it will be, see, 3-bromo. Okay, then 1, 2, 3 and 4, right? On the 2nd carbon there is a methyl group attached. So 3-bromo, 2-methyl, right, butane. Okay, 3-bromo, 1, 2, 3, 4. So 3-bromo, 2-methyl butane. Now coming to the 3rd example here, again this one should get your smallest number, right? So if you see 1, 2, 3, 4 and 5. So 1, 2, 3, 4 and 5. So on the 3rd carbon there is a methyl group, and 4th carbon we have bromo group. So if I write the name for 3rd one, it will be 4-bromo. Okay, okay, sorry, this is not butane, there is a double bond, right? So it is but, and if you see on what position, but first in 1 ENE you can write down. Now similarly here 4-bromo, so 1, 2, 3, 4. Then on the 3rd carbon 3-methyl, 4-bromo, 3-methyl, and then there is 5 carbon, so I can write pent. Okay, and then on the 2nd carbon there is double bond, pent 2 ENE. Okay, now coming to the next one, 4th one, if you see, 4th one. So if you see now here there is a trick. If you see, if you number from this side, we'll get 1 and 2. Okay, and if I number from this side also, I'll get 1 and 2. So the double bond, any way you number it, double bond is coming on the 2nd carbon. So it will be done in such a way. But if you, so double bond we can do 1, 2, 3, 4 also, 1, 2, 3, 4 also, it is correct. But now if you do from this side, okay, then bromine will get the least, like bromine will get 4 number, okay, but if you do from this side, bromine will get 1 number. So the substituent should get the least number, that is the rule. So the correct way or the correct order of numbering should be from here, that is this bromine carbon should get your 1, okay, so this is 1, so 1 second, okay, so this carbon is 1, this is 2, this is 3, and then this is 4. Okay, so now if I want to name it, so I'll get 1, 2, on the second carbon it is methyl, so I can write first 1 bromo, okay, 1 bromo, then I have 2 methyl, okay, 1 bromo, 1, 1, 2, 3, 4, so I have but 2 ene, right, 1 bromo, 2 methyl, 1, 2, 3, 4, but 2 ene, okay. Now coming to the fifth one here, so if I write next one, so if you see this is also, if you see number from here, this will get 2, this one will also get 2, so I will number it from this side, 1, 2, 3, sorry, this is 3 and this is 4, okay. So, okay, now if I see number this one and I write the name for this one, it is 1 bromo, okay, then we have but 2 ene, okay, simple, 1 bromo, but 2 ene. Now if you compare this one here, if you start numbering, so if I number from this side, this double bond will get 1 number, but if I number from this side 1, 2, double bond will get 2 numbers. So I will number from this side 1, 2 and 3, right. So the name will be, I will write it as 3 bromo, right, 2 methyl propene. Okay, so you have to remember double bond should be given first priority and then halogen, but if double bond is getting same priority on both the sides, then you should get priority, you should order in such a way that then the halogen gets the lowest priority. Okay, now coming to this, drawing the structure. So here are some compounds given, you just need to draw their structure. This is very easy. So 2-chloro 3-methyl pentane. So the first thing you should do is you have to draw the parent chain. So in parent chain there are 5 carbons, so we'll draw like this, 5 carbons. Then 2-chloro, so on the second carbon there is chlorine and on the third carbon there is methyl. Okay, the rest of the things you can balance with hydrogen. So each carbon should have 4 bonds. Okay, so this will be the structure. Now coming to the second one here, 1-chloro 4-ethyl cyclohexane. So we can draw cyclohexane here. Okay, this is 1-chloro and on the fourth side I have ethyl. So this is 4-ethyl cyclohexane. So this is 1, 2, 3 and 4. Now coming to the third one, if you see it is 4-tert-butyl 3-iodoheptane. Okay, so now first we'll do heptane. So that is 7 carbon, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now we have 3 iodo. Okay, on the third carbon we have iodo and fourth carbon I have tert-butyl. So if you remember, tert-butyl structure is this one. Okay, so 4-tert-butyl 3-iodoheptane. Okay, just arrange, balance the rest of the carbons with hydrogen. Okay, so I'll get CH2 here, I'll get CH here, I'll get CH here, then again CH2, CH2, CH3, here also CH3, CH3 and here also CH3. Okay, now coming to the fourth option, if you see it is 1,4-dribromo but 2-ene. So first we will do but 2-ene, this is but 2-ene and 1,4-dribromo. So on one position and fourth position we have bromine group. Okay, next arrange, balance the rest of the things with hydrogen. Okay, then 1-bromo 4-sec-butyl 2-methyl-benzene. Okay, so first we will do benzene. Okay, benzene is done. 1-bromo, so on the first carbon I will write bromo. On the fourth carbon, that is secondary butyl. Okay, so if you know secondary butyl structure is like this, this is secondary butyl, then 2-methyl, on the second carbon we have methyl. Okay, so this is the structure for the fifth option. Okay, so these are the structures, very easily you can draw. Just first remember, first you have to do the parent chain, then whatever positions are given, just add the corresponding substituents there. Okay, fine. Next, coming to the nature of CX bond. So nature of CX bond, you have to understand that carbon is like this. Halogens are more electronegative than carbon. So halogens will have a delta negative charge, carbon will have a delta positive charge. Okay. So halogen atoms are more electronegative than carbon, therefore carbon halogen bond of alkyl halide is polarized. The carbon atom bears a positive charge and the halogen bears a partial negative charge. Okay. So I can say that CX bond is polar in nature. Okay. Fine. Now let us practice some questions. Before that, we will do that question that I gave you in my previous section, this chapter, like from your coordination compound, last chapter that we completed. So that is your MC pi bond. So MC pi bond is formed by what? So if you remember, MC pi bond, filled d orbitals to empty anti-pi star anti-bonding orbital donation was there, right? So if you see here, it is bonding, so we can eliminate. Empty bonding we can eliminate, and then donation of electrons pair, electron pair of filled metal d orbital to empty anti-bonding pi orbital of carbonyl. This is correct. Donation of electron from pair of half filled metal d orbital, so there is no half filled, it should be fully filled. So the correct answer for this question is option number C. Okay. Fine. Now let us do some PYQs. The correct IUPAC name of the structure. Okay. So now if you see, we have this is a benzene ring. Okay. So we have 4 ethyl, 1 fluoro, 2 nitrobenzene, 1 ethyl, 4 fluoro, 3 6 fluoro, and 5 2 ethyl 2 fluoronitro. So the substituent should be in such a way that their addition should be giving you a least number. Okay. So now if you see here, it is 4 ethyl 1 fluoro, or I can say so we can add for option A, what are the substituents? 4 and 2. 1 we do not count, 1 fluoro we did not count, 1 and 4 ethyl and 2 nitrogen, so 4 plus 2 is 6 here. If you see here, 4 plus 3 7, so this cannot be the answer. 6 plus 3 9, here also we cannot be the answer. 5 plus 2, here also it is 7. So we need the lowest value. The substituents should be arranged in such a way that the number or the carbon number on which the substituents are present addition should be a least number. Okay. So that is why the correct answer is 4 ethyl 1 fluoro 2 nitrobenzene. Now 1 we are not counting because in none of the options 1 is given. Okay. The correct answer for this question is your option number A. Okay. Now coming to next one, the compound having the longest CCl bond. So longest CCl bond will be there if it is a single bond. Okay. So now if it is a single bond, then it will be longest bond. Okay. Now what happens if you see these options? Okay. Now if you see these options here, what happens? Resonance takes place. So there is a partial double bond here. So this is not a pure single bond. If you see here, this is a pure single bond. Here also resonance is there. So this is not a pure single bond. Here also resonance is there. So this is also not a pure single bond. The only option where there is a pure single bond is option number B. So the correct answer for this question will be option number B. Okay. Now coming to question number 3. Which of the following statements is true in case of alkyl halides? Okay. They are polar in nature. Yes, we have discussed. They can form hydrogen bonds. Yes. They are highly soluble in water. They undergo addition reactions. Okay. So if you see, we will discuss it in the next class also. The solubility of alkyl halides is very less in water. Okay. They have less solubility in water. Okay. So that is why this statement is incorrect. Okay. So let us see the next question here. What is the common name of 3-bromopropene? So if I draw this one, so my structure will be like this. Okay. So this is 3-bromopropene. Now if you see, this carbon which contains the bromine is attached to a carbon having double bond. So these type of carbons or this type of haloalkanes are called as allylic, right? So it is allyl bromide. So the correct answer for this question is option number C. Now how many carbon atoms does isobutyl chloride have in its parent chain? So if you do isobutyl structure, okay, so this is isobutyl structure, okay, isobutyl chloride. So I can draw like this. Okay. So now if I name this, this is the parent chain. Though what is its IUPAC name? It is 1-chloro 3-methyl propane. Okay. So in the main chain of isobutyl, in the main chain there is only 3 carbons. So the correct answer for this question will be option number B. Okay. So yes, now this is a homework question. You need to write the IUPAC name of this particular compound is given to you. So draw the structure and then try to write it IUPAC name, and do not forget to comment down the answer in the comment section. Okay, so yes, so we are done with the first lecture of haloalkanes and haloarenes, first lecture of organic compounds, where we have discussed some basics, that is your classification, nomenclature, structure. Okay, these are very important to understand the rest of part of this chapter. Okay, so I hope you have enjoyed this lecture, you have understood everything. If you have any doubt in any of these concepts, please comment down, I will definitely address it. Okay, and if you are liking this series, if you are following my channel, following these videos every day, then please do not forget to subscribe the channel so that you can see much more videos like this. Okay, and do not forget to join our WhatsApp channel. The notes and everything will be available there, and please do not forget your target 60 out of 60 in KCET Chemistry 2025's exam. Okay, so yes, see you soon in the next episode of this series, where we are going to discuss the methods of preparation of haloalkanes and haloarenes. Very, very important lecture. Please do not forget, every day 6 PM we will be meeting. Okay, thank you and all the very best for your KCET 2025 preparation.